This episode was proudly made possible by the all-new 2015 Subaru Legacy. It's not just a sedan, it's a Subaru. Movies in space are awesome, don't get me wrong, except when it comes to sound. But if space is a vacuum, there's no sound. So maybe space isn't a vacuum. Can you hear me, D-News fans? Hello? Hey, it's Trace here, and I'm not in space. And if you're not in space either, then you should be able to hear me just fine. As regular viewers already know, sound travels using a medium, and sound is a mechanical, longitudinal wave of energy emanating from a vibration. For example, when a guitar string vibrates, the atoms of the metal string hit the atoms around it, and that vibration is passed along to the next and the next until it gets to your ear. Once there, the tympanic membrane or eardrum vibrates at the same frequency, and the tiny bones in your middle and inner ear translate that movement to energy that your brain can interpret. Because all atoms can vibrate like this, sound can travel through solids, liquids, and gases. Outer space, on the other hand, is thought of as a vacuum. The absence of matter, and no matter means no sound. But really, in space, it's more like atom, atom, atom. NASA says there's like 1 atom per cubic centimeter. If you look at all those free-floating atoms and you took them all into account, you'd have 90% hydrogen, 9% helium, and less than 1% of other stuff. Which makes sense considering the makeup of everything we know in the universe, am I right? Even though 1 atom per cubic centimeter might seem like more than you would have thought considering it's a vacuum, it's still fantastically thin out there. With such low density, sound's energy waves can't bounce from one atom to another. No atoms, no waves, and no sound. So George Lucas, you're wrong! Ha! Spaceships don't make noise unless they're flying within the atmosphere of a planet. And not just our planet. You can hear sounds on other planets too. For instance, sound travels faster on Venus than it does here on Earth because the atmosphere is thick and soupy, says Tim Layton of the University of Southampton. This means if you could talk on Venus, the sound would zoom through your vocal cords, but deepen in pitch because of the makeup of the air. Basically, you'd sound like a bassy Smurf. We get around this by building structures that contain pockets of air in space. The atmosphere inside the International Space Station sounds pretty normal.
Here comes the sun.
But if an astronaut hit his helmet against something outside, only he would hear the impact because his helmet has air, but the people inside the station wouldn't hear anything. Purely hypothetically, if somehow you could put your bare head against the outside of the International Space Station, you might be able to hear Chris Hadfield inside playing his guitar. See, that guitar vibration would travel through the air inside to the walls of the ISS, vibrating them, and then if your bones were touching just right, that vibration might translate through your bones directly to your inner ear. This is called bone conduction, and it's used in some headphones and in tech like Google Glass. Because your bones conduct that vibration, it surpasses the need for air and doesn't require your eardrum at all. But again, it would only work if your bone was actually touching the ISS directly. Plus, of course, you'd die pretty quickly because you would be in space. So, no sound in space, oh well. There is another way to pull sound directly from space though. Not in an atmosphere or in a spacesuit. Can you guess what it is? Tell me your guess in the comments. If we get 7,000 likes, I will release a follow-up video with the answer. We want to extend a quick thank you to Subaru for making this episode possible, and especially the all-new 2015 Subaru Legacy. Every sedan has its benefits, but only one combines them all. It's not just a sedan, it's a Subaru. Thanks for watching D-News, everybody, and please subscribe.